got a power supply set to 15 volts. The current is very, very low because the only thing this power is doing is attached from one side to the other. There it is. From one side to the other of this piece of paper, which is a little bit conductive. Not very, but a little. How loud is that ambient noise for you all? The HVAC just kicked on. Can you all still hear me?
Yeah, we can hear you.
Yep.
Cool. Okay. So, I'm going to try, this is my high-tech setup here. It's a chair. I'm going to try, just balance my phone so that you all can still see what's going on. Beautiful. The light is a little weird. Apologies for that. I'll get the setup straightened out going forward. Other thing I need. Come on. Is a voltmeter. And that's visible to you all, yeah? Awesome. All right, cool. The cool thing, like I said, about this paper is that it is conductive. Where'd my backlight go? There we go. So if, for example, I connect one of the leads of the voltmeter to one of the terminals coming from the power supply, and touch the other lead to the paper, we are able to discern that there is an electrical environment in the paper. That the paper itself is the medium in which an electric story is taking place. Let me zoom in a little bit here. The geometry telling this story, there's a circular dot, circular region of conductive paint on one side, and a circular region of conductive paint on the other side. And the rest of the paper is clear. We've connected that dot to one of the leads from the power supply, and the other lead from the power supply is connected here. And we have two sort of questions of interest. If there is an electric environment, an electric terrain going on here, what does it look like? If it is an electric terrain, how does the terrain, like if I wanted to hike this terrain, if I were a charge, what would it feel like to walk through this paper, to move around in this electric environment? There's two things we need to do to answer this question. The first thing, if it's an actual hike, I'm worried about the topography. Where are the hills? Where are the valleys? How is this? Is this a very steep hike, or is it a kind of a flat hike? What is the character of this terrain? And the way we're gonna kind of track that is with equipotential lines. In other words, contour lines. We're going to make a contour map like this were, hills and valleys. We're going to mark all the points in this environment that have the same potential. All the points on the map at which a charge Q would have equal potential energy in this electric environment. Kind of like we were talking about yesterday in the vector field that I shared with you. The hypothetical charge Q isn't really of interest. What's of interest is the environment that would create a potential energy for a charge Q in that environment. So it's the environment that we're actually trying to assess here. I don't necessarily care what charge we put anywhere, and in fact, I'm not going to put any charge anywhere. With our voltmeter, we will assess the character of the electric environment, and then we could imagine a charge Q navigating that environment. Okay. So maybe there's a better place I can put this so that it's a little bit easier to see. Can you all see that voltmeter screen? And if I touch the paper, can you see that the measurement has changed to 8 volts or so?
Yeah, we can see that.
Yeah, cool. So for now, I just want to figure out what are the limits. The experimental handout suggests that we should pick a handful of voltages evenly spaced between 0 and 3. But we've already seen that we have potential measurements, voltage measurements, that go up to 8. So I kind of want to see what the story is here. What are the voltages we have? Something close to 0, about 1.5. 4, 5, 6. We're getting up to 14 on the other side almost. 14.7 if we go all the way from one of the power supply leads. Oops, the video froze. Hold on, my phone went to sleep. Damn it. all the way up to 14, almost 15 on the other power supply lead. So on the paper itself, we can get up to maybe 12. Yeah, 12 or so. So it looks like we can talk about measurements between about 2 and about 12. So you tell me, what's the first voltage between 2 and 12 that you would like to find a contour for? Okay. We've got 2 votes here, 2 votes, 1 vote for 2 volts and 1 vote for 5. I think let's try both. I'm here pretty close to 2, so that's what I'm going to pick because I'm lazy and I don't want to have to go find 5. So now the story is that I'm asking you to sort of play along at home with a numbered grid, kind of like this. I've got a grid that goes to, I think this is a centimeter grid from 0 to 20 and 0 to 28. And when we find the spot where 2 volts is, I'm going to ask you to make a note of the sort of XY coordinate where that is. And then we can draw a connection for that, for all of these points that have 2 volts. And I'm going to do the same thing. I actually have a piece of paper with I'm cheating, right? Because I stole this from the lab. But I've got a piece of paper ready to go. And I'll record the data together with you. But I think it's a good idea if you record it as well. So let me get something to write with. So we're looking for 2 volts. All right, so do I get closer? All right, it looks like the closer I get, the smaller. Okay, that's too close. Whoop. 2 volts. Awesome. And actually, you know what? I'm going to change these. Oh, shit. I'm going to change the scale because I don't want so many decimal places. 2.0 is just fine. 2.0. So where are we here? This is just to the right of an x coordinate of 2 and a y coordinate of 10. Just a little ways past that point. Does it make sense, the method I'm using to take the data? Cool. So that's our marking for 2 volts, and again, that's right there. just to the right of 2 and 10 centimeters even. So I'm going to go mark that on this sheet. Right about there. So just to show you what I'm doing, marked a little dot right there just to the right of 2, and I called it 2 volts. Okay. But I want to try to find, if I want to draw elevation lines on a contour map, I need to find all the points in the environment where that's the story, that are that elevation above sea level. So now I've got to go hunting for other points that have the same voltage. Let's say maybe here. Okay. So that's a coordinate of 1 centimeter. Just below 9. About halfway between 8 and 9. A little bit closer to 9 than 8. So I'm going to leave that there. Make a mark 1 centimeter. Just under 9. Where else should I look? Okay, that's too big. 311. Okay. 2, 3, 11. What should I do?
Go down.
What?
Could you like move it? Maybe 3, 7.
3, 7. .5 11 right? So like somewhere here. Looks like just like 2 even, 11 even is really close. It's varying pretty quickly. I mean, that's close enough for me. 2 comma 11. I'm happy with that. Where's next? Now, when you say 11.2, do you mean down here?
I actually wrote it wrong. I meant like 211 earlier, so never mind.
I'd like 0.8. I'd like a few more points just so I get an idea of the shape of things, and then I can kind of sketch a connection, you know, kind of connect the dots roughly. 0, 8, 1.5, 12. All right, let's try 0, 8. That's pretty close. Yeah. Move a little bit. Yeah, 0, 8. That's pretty darn close. Okay. One and a half, 12. Oh, somewhere there. Maybe 1.5, 11.5. Getting there. One, 10.5. Maybe 111. Hey, all right, wait a minute. What about 111.5? Just a little bit lower than that. Yeah, somewhere right there. Just, yeah, like 11.25. One 11 and a bit. Okay. That's pretty good. Is there anywhere else on the paper that we expect to be that is for five? Like the further away I get from this spot, the greater the numbers seem to get. Oh shit. Four point 3.6. Anywhere else I should try?
Can you try 3.5?
3, 5. Oops, that's 4. That's 5, 5. 3, right, I can math. 3, 5. Four 12. I mean, that's a nice spot for 4 volts. So if we wanted to draw a contour for 4 volts, we could make a point there. 2, 6. Again, we're not that far from 4. A little bit further away gets us to 4, I think. So here's that's what I've just done. I kind of connected the dots, and there's a rough sort of parabola looking thing. I mean, I expect it, I think, to be symmetric, one side of the paper and the other, because the geometry has symmetry around the line halfway through. Well, actually, it's got symmetry this way too, but you know, being this far away from one and that far away from the other, that happens twice, one here and one here. So can I make that inference? Like, are you willing to buy that? I don't. It's your data, not really mine. So I'm just making shit up. It like. So I guess to be sure, 0.8 was a good point. Maybe 0.12 is a good point. Just to see if it makes this kind of parabola shape. Just to check really quick. 0.12. Yeah, okay. So I think I'm in the clear. I think I'm willing to argue that we can make this sort of parabola shape. What do you think? Cool. Next voltage. Someone suggested 5 earlier. Should we try for that? Mm-hmm. 4.5. Almost 5. Maybe here. I found a bunch of places where it's 4.9. 4,16. No, 4,12, I think. Yeah. Looks like 4,12 is pretty close to 4. Yeah. Okay, so let's draw one for 4 because we found that one. 4,12. Okay. And mark that one. 4 volts. Okay. So what's next? 2,6. Well, what about 3,6? I think I like 3,6 better. I mean, 4.1, kind of close enough, right? I mean, I gotta move like 2 millimeters to get to 4.0. Close enough. 3,6. Happy with that. 3,6. Where's next? Keep them coming. How do I make this window bigger? Can I make this window bigger? Here we go. 3,10. How do you feel about 5,10? Five comma 10, 3,18. Well, I can't even get to 18. 3,18. That's a little too far. Maybe 3,16. No. 3. Well, there's one. 314 and a half. So that was 510 and 314 and a half. 510, 314 and a half. Okay. One or two more. Let's see. 5-8. 5, 8. It's pretty close. Do 8, 4.5, like 4.5, comma 8. It's pretty close. 4.5, comma 8. 4, 8 even. A little too little. So we got to split the difference. Call it 4.5. 2, comma 4. Wait a minute, come on now. About 2, 4.5. I'm good with 2, 4.5. 4, comma 12. Boy. We do 4.5, 12. Okay, so wait a minute. I said 2, 4.5, and 4.5, 12. 2, 4.5, 4.5, 12. Well, we already had a point for 12. That's interesting. We've got two values here. 4, 12 was already a good one, I thought, but it looks like 4.5, 12 is better. Or, well, somewhere to the right of 4 anyway. Yeah, it looks like 4.5, 12 is a little bit closer. I'm going to skip 4, 12 and change it for this one. $16.5, 0. Hey, good call. 16.5, or I mean 0, 16.5 actually. 0, 16.5. 4, comma 4. That's a little too far off. 6.5 up, 6.5 down. 0, 3.5. Just playing the symmetry game. Yeah, I think this is enough points. 0, 3.5. I mean, I feel pretty good about that. It's got a nice kind of symmetry to it. Pretty regular. Nothing looks crazy out of place. And even if we had kept 4, comma 12, it wouldn't really made too much difference. There'd have been a little weird divot there, but not too bad. All right, what's next? All right. Do you want to go by twos? Okay, that's cool. 9.5, 10. Eight comma 10 is a little too little. That was my first thought too, but so we got to get further. 5.8 is almost there. 6.2 is a little much, so call it halfway. 9.5 comma 10. 6 volts. Someplace else? Eight comma 7. I'm just hunting at this point. Oh, getting warmer.
Phone locked.
Uh-huh. Sure did. There we go. I don't know. Doesn't look like. All right, what about 9? Close enough? Six. All right. Yeah, okay. 8.5 comma 0 is what I've got here. What do you think about that? Yeah, I like that one. Does that change your expectations? I mean, it's interesting, right? Like if I were following along, I kind of would have expected a curve more like this, much closer here, like 6 comma 3 and junk like that. So far, we've only got 2 points, but it looks like, you know, this is a much shallower contour. I mean, I definitely want to find a couple more points, but this was a surprising result to me. I expected to be way over here. Yeah, it doesn't, right? Like the pattern has changed. 8.5, 20. Oh, so you're just playing the symmetry game. I approve. I'm a fan. I don't know. Yeah. Unfortunately, the indication to not remove the tape on the sides gets in the way. I can't choose 8.5, 20. Sorry. But what if I choose, I don't know, 9.19? Close enough? I'm good with it. 9 comma 19. Should we get a couple more? I wonder if the other volts will make a cylindrical pattern with parabola shape going the other way. Like once we cross x equals 14. It is an excellent thought. I'm curious to find out. Let's find. I mean, I'm gonna look for another one somewhere in here, somewhere like I don't know, 9 comma 15 or somewheres. Let's make it, I don't know. Yeah. It's not far enough. See that? Okay, there we go. That's 9.5, 15. All right. So I'm going to try 9.5, 5. 9.5, 5. And play the symmetry game. All right, so I'm cheating a little bit. It's like 9.25, but close enough for jazz. I mean, I don't know. I think we're good with 6. I'm willing to say that it's this kind of really shallow contour just basically comes across like that. I mean, yeah. I'm pretty convinced anyway. Like, should we move on to 8?
Good.
Okay. I've got 8.5 comma 0, like 9.3 comma 5, 9.5 comma 10, like again like 9.5 comma 15, and 9 comma 19. All right, so let's move on to 8. Fifteen and a half, 10. Okay. Where to next? I guessed 16.4. Eighteen two. Whoa, what's going on there? Okay, that's better. 16. Did I just get the same reading at 16.2 and 16.3? And 16.4? I sure did. Okay, that's weird. What the hell? All right. 16, 18. Sheet a little bit farther out. It's close. 16, there it is, 16 and a half. Oh, wait. Yeah. 16 and a half, 18. All right. So we got 15 and a half and 16 and a half. And it looks to me like up here, anyway, I'm curving away, kind of like I curved away from the center line on this side. But over here, like, well, we're just flattening out. So I kind of want to look for a point down here to confirm my suspicion that that we're curving away from the center line here. I don't know. I mean, 16 and a half, 16 and a third. Yeah, 16 and a bit. Yeah, 17.1 is what I thought, but that's already. Oh, wait a minute. What the hell? Yeah, there it is, 17.1. Well, wait a minute. 17.1 is a little high. 8.2. So 16 and a half, 1. We were close. All right. Yeah, this is super, like, it's really close to 16 all the way across. X equals 16. I agree. Barca, I think it is curved the other way, towards the right of the situation here. Um, I mean, like, we could try to look for more points, in this region here to kind of smooth out the curve, but we're splitting hairs, right? We're talking about the difference between 15 and a half and 16, and then, like, well, all right, well, how precise can we actually be with this stupid little needle? Is it Is it 16.647 or 16.648? Like, we don't have that kind of precision, you know? So I'll be honest with you, I'm getting bored. Like, with 8, like I want to move on to 10 and see something more interesting, you know? So I'm gonna kind of cheat and call it that. What do are you all willing to come with me on that? Cool. Where should I look for 10? No, not 20, but 21. Yeah, 21:10. That's perfect. Oops, wait a minute. My video froze. Yep. Hello. That's a picture of my desk. There we go. I just needed to wake the thing up. 21:10. Let me try that again. Yeah, 21:10 right there. Spot on. Okay. 21:10. Beautiful. Same y coordinates further down. The same y coordinates as we had for okay. Nineteen comma 1. Twenty-two 4.
Sorry, my computer or your screen froze for me. Was 19-1 one of the points?
19:1? No.
Oh, sorry. I thought you said that. Never mind.
It's a point that we tried, but it's only 8.6. Yeah. 21.5. 8. That's pretty close. Yeah, that's like 21.25, comma 8. Okay. Twenty-two 4. I want to look at that one again. It's close. but 23, 4 is closer. (23.5), comma 4. Yeah, well, it's a little 20. Okay. 23 and a bit, 23 and a third and a quarter or so, comma 4. Okay. Where to next? So here's what I'm thinking. I'm starting to think that there's some real symmetry to this. And I'm gonna just pick 23 and look on the other side up here until I find 10. Not too far, too close. Says 23, almost 16. Just below 16. Yeah, 23, 16. And I've got one more thing that I want to check. Is it kind of shallow? Like, does it come around down towards 26? Or does it curl strongly and come around to like 26, comma 3? I want to check that. 26 even? Nope. How about 26.3? All right. 26.2? Got it. So if 26.2 is a spot, should I look for 26.18? Nope, that's 26.18. Nope, but that's 17. There it is, 26.18. So 26.2 and 26.18. (26.2) and 26.18, and that's the story, at least as far as my grid goes. It's interesting. The conductive paper goes up to 28, but the photocopy that I'm working on only goes up to 26. I guess I'm not cheating as hard as I thought I was.
What were the points for the 10? One more time.
We just found 26.2 and 26.18. Another one was 23, just less than 16. 21, 10. 21 and a quarter, 8. 23 and a quarter, 4. And I've got that kind of contour. I'm gonna look really quick for 12 volts. Should be only, yeah. Just under. Let's see. There's one. 25, 9. And 25, 11 and a half or so. 25, 9, 25, 11 and a bit. There's one, it's like 24 and a bit. All right. 25, 10. Well, that's weird. Okay. What about 26, 8? This is pretty close. Yeah. And 26, 12 and a half. 26, 8 and 26, 12 and a half. All right, good enough. Something like that. It's a little bit weird, kind of flattened, but just, whoop, what the hell? Just a little circle there. So if this were a topographical map, what would this terrain look like? looking at it, so it's kind of flat in here. Like we're still as we move to the right, we're still going uphill.
Can't see anything.
Very strange. As we move to the right, we're still going uphill, but we kind of go uphill the same way whether we're along the middle line here or over here. I mean, maybe we're getting from 6 to 8 a little more slowly here. Like we've got to walk farther to get from 6 to 8 than we do here in the middle. So the terrain, as we get further this way, becomes flatter, and over this way it becomes flatter. The slope decreases. The as we get close to one side or the other, it looks like things get more closely spaced, right? Like to get from 8 to 10, we got to go 1, 2, 3, 4, 5 clicks. But to get from 10 to 12, we only have to go 1, 2, 3, 4 clicks. To get from 2 to 4, we only have to go 3 clicks over here. So the closer we are to those nodes where the power supply is connected, the faster things change. Okay. Any questions about what all we just did?
So I'm having kind of a hard time with like the idea of like equipotential lines versus field lines.
Cool.
So like, is the field line like going straight across and the voltage increases, or is a field line like all the same volt in one line?
The field line isn't the second one. That's for sure. These are equipotential lines, lines of equal elevation electrically. Like it's like say we're like it's like the electric elevation all the way along this contour is 8 volts. That we're all it's the same gravity, the same gravitational potential energy if we want to think about terrain. It's not a force due to gravity. Gravity wants to push us downhill, and this is like it's perpendicular to downhill. It's along the hill. So this is like we walk uphill a certain ways, and then we stop, and then we walk around the hill without changing our elevation above sea level. That's what these are. These, 6 volts, 8 volts, 10 volts. They're contours that connect all the points that have the same height above sea level or the same electric potential. If we want to talk about field lines, then we've got to move on to the second part of the lab. All right, I need a thing. Hold on. Super high-tech equipment here. Ready? I keep it in pressurized containers. No, it's just a bottle of seltzer. What I need is the bottle cap. So I've got my voltmeter lead stuck through the center of the bottle cap. Maybe. Maybe. There we go. And now I'm going to measure voltages again. But now I want to pretend if I'm a little charge Q and I get dropped onto this electric terrain, what's going to happen to me? I'm going to roll downhill because that's how terrain works, right? If I drop a little marble on a hill, it's going to roll downhill. But which way is downhill? The way that is the way that the electric environment tries to get me to go. The electric force on charge Q, that's the electric field. So if we can follow the trajectory of that charge rolling downhill, that's our field line. So I'm going to use the bottle cap as like my step size. And what I'm going to do is figure out, okay, if you put me here, where around me is the terrain steepest? Because that's the way I'm going to roll. Let me show you what I mean. I don't want to measure relative to the bottom anymore. I want to, from where I am, I'm going to roll a little bit which way. I'm going to pick a point, I don't know, here. And then I want to measure the difference all the way around. And I'm looking for the largest possible value all the way around the bottle cap, because here I am at the red voltmeter lead, and the way we were putting things together a second ago, the black voltmeter lead was down at the bottom, down close to the part where we were 2 volts, not 12. So the red voltmeter lead, as we went farther away, was the uphill lead. So I'm going to keep that convention. So I want to find a spot with the black voltmeter lead, the downhill lead, that is the furthest downhill, the steepest descent from the uphill spot where the red voltmeter lead is. Does that make sense to everybody? Okay. Yeah. Before, when the black voltmeter lead was down here and the red voltmeter lead was up here, we were measuring positive voltage because the red voltmeter lead is uphill of the black one. So now I'm going to keep the same relationship. Here's a spot and I'm somewhere up. Here's a spot, and I'm uphill of some places and downhill of other places. If I'm uphill of some places, I want the voltmeter to read positive, because that's how it's been working before. From black to red, positive when we go uphill. If the voltmeter reads negative, it's because it's backwards. Right now, I wanted to put the black lead downhill of the red one, but it's the wrong way. It's uphill now because it's closer to the high voltage spot. I'm looking for the point where the downhill voltage is greatest, because that's the direction I'm going to roll. Point 24, point 34, point 40. Back down again. So it's somewhere. Somewhere here. That now the black voltmeter lead is at the point where the voltage hill, the terrain between the black voltmeter lead and the red one, is the most different. That's steepest. This is the downhill direction. And if I put a little charge in this electric environment, from red to black is the way it's going to roll. Does that make sense to everybody? Okay. When the answer is no, you got to ask a question so I know. Just the takeaway. All along today, we've been using the difference between black and red to mean uphill or downhill, depending which way you look. If you look from black to red, that was uphill. But if we look from red to black, that's downhill. And I'm looking for the point around the red. It's the same distance away. So we take one step, only one step. We're going to roll for just a little bit. In which direction does the terrain change the fastest? Which way is the steepest downhill? Because that's the way we're going to roll. Yep, downhill, from red to black. What? Maybe. Could be off the page. Not always, I bet. Let's find out. So I'm going to get a different a different writing utensil so that I can keep track of the fact that these are different kinds of things that I'm tracking. I'm going to get a pen. And I'm going to start from I'm going to start from 26, 6. And I'm going to look for the steepest downhill step I can take. Oh, well, fine then. .33, 0.54, 0.50, oh, 0.61. No, somewhere over here. .57. I don't know what happened to that 61. That was nice. .59. So I'm saying that from 26.6, I'm going to head towards 25, 1, 2, 3, 4, 5. Oh, for. This isn't going to work. Hold on. I got to plug my phone in. Oh, my goodness. From 26.6. .5 is this way, so I'm headed to 25, 4.5. Does it make sense, the logic I'm using, everybody? Okay. Yep. That's right, Brittany. All right, cool. So I'm going to stay there. I'm going to mark 26.6. 1, 2, 3, 4, 5, 6. And 25, 1, 2, 3, 4.5. And then I'm going to use 25, 4.5 as my new spot because that's where I went. Where did I put that phone cord? It's over there. Okay. Yes, charging. Yes, good. Okay. So I'm going to start from 25, 4.5. Somewhere there. And try this trick again. Yeah, but you should have your own too, right? So again, I'm looking for the greatest step, the steepest descent from red to black downhill. And it looks like somewhere right around there. 0.4, 0.41, 0.42, something like that. So I headed to, let's call it 24.3. And if we start from 24.3 and look again, what's the step? Which direction is downhill the biggest? Okay. Two. 0.35. Okay. So that's 22.5, 2.5. 22.5, 2.5. Okay, start from there, 22.5, 2.5. Look again. 0.35, 6, 7, 8. Four, 2. Okay. 3, 7. 3, 7. Okay, 3, 7. 21, 1 3/4. Okay, start from there. Hmm. 33, 4. Six. 5, 36. That's about right. 19.5. 1 1/4. Just to point this out, the descent, the steep descent that I keep trying to make, has taken me away from the high point here, and then I curved back towards the, I didn't just run off the page, which is really interesting. The previous point was 21 1 3/4. Yep. So I'm gonna keep going from $19.5, 1.5, 1.25, 19.25, somewhere there. Video froze again. $18.1. Okay. Start from 18.1. $16.5, 1. Interesting. Oh shit. There's a picture of a flower. Enjoy that. But you heard me say the coordinates for the points, right? The last couple I did were 18.1 and 16.5, 1. Yep. $16.5, 1. There. Four. 15.1. From 15.1. 3, 2, 4, 3, 4, 4. Where'd that go? 13.5, 1. From 13.5, 1. 28, 33, 35. 38, 39, somewhere in there. Okay. 12, 1 1/4. You know, this would go faster if it were a bigger bottle cap, but if it were a bigger bottle cap, then we wouldn't get a nice curve. We would get like jagged steps because the direction would change too much from step to step. So it's a little bit tedious, but it kind of has to be in order to get a nice picture of, you know, we go this way, this way, this way, this way, and if we take too large steps, then we don't get a good picture. Where were we? 12, 1 and a bit. Something there-ish. The other thing is it'd be nice if it were a clear bottle cap so I could see through to where I was putting the red lead. So there's some, you know, some experimental variation we expect, but it's close enough. It gets us a good idea of what's going on. That's uphill. That's too far. All right, come back around. 36, 38, 40, 40. 10 and a half, 1 1/2. Ten and a half, 1 1/2. Nine, 1 3/4. Nine, 1 3/4. 31, 34, 35, 36. Y'all gonna make noise so I know to look over. There's that same picture of a flower. There we go. Where was I? 9, 1 3/4. We're almost done. Eight, 39, wait. Seven and a half, 2. It's uphill. Oh, wait. All right. 38. 36, 37. Six. I don't know. 1.5, 1 3/4. Depends how you want to count that. Right here. Three, 5. Call it 4.5, 3.5. We're so close. 4.5, 3.5, somewhere there. 42, 41. Oh, back the other way. 41, 42. 3.5, 4.5. Start from there. 40, 50. 1. Well, all right, there it was. 8. Wait, where'd it go? 48, 49, 50. I'll take it. 2.25, 5.5. Quarter, 5.5. 58, 59, 60, 62, 66. Wrong way. 66 is the biggest number I saw. So 67. So 1.5, 6 3/4. One more. 50. 72, 89. 3/4, 8. That's what I ended up with. Oh, for fuck's sake. Jesus. that at each successive point downhill was in the indicated direction. So we went, draw now. We went this way, this way, this way, that way, around, this way, that way. Does it make sense? What happened? Why it looks the way it does? And like what it is that we're evaluating when I'm like looking around the bottle cap for the largest possible voltage? All right, cool. How the bottle cap changes it. Changes what? The biggest difference before in the first part of the lab, we kept the one lead all the way at the bottom, all the way at one end, and we kept looking uphill relative to that. Where are all the points that are 6 volts uphill of that? Now that we're using the bottle cap, we're looking for all of the points only a bottle cap radius away we're looking for the point that is steepest downhill away from the red lead. That there's only one. There's only one place that is steepest descent, steepest downhill. Instead of looking for all the points, you got it. At this point, 2 things have to happen. The first thing is that I need to go get my laptop cord because now my laptop's about to die. The second thing that needs to happen, I'm going to give you and Sean some time to chat about the questions at the end of this lab. I know that we haven't finished. I still want to draw at least one other trajectory line, but I think because you now know what's going on, that I'm just going to take that data really quick, notate the coordinates for the points, and then share that with you as soon as I go get my laptop charger. Okay, so I'll be right back. Y'all discuss.